Hey there! How much do you know about cystic fibrosis? Do you know a little bit or do you know a lot? I'm here to make sure you know a lot. Follow me and let's go over the basics before we dive in deep. Some basics we might know about cystic fibrosis is that it's an inherited disease of the mucus and sweat glands. It affects mostly your lungs, pancreas, liver, intestines, sinuses, and sex organs. The CFTR gene is mutated in individuals with cystic fibrosis and consists of debilitating symptoms such as salty tasting skin, frequent lung infections like pneumonia or bronchitis, and weight gain. I didn't know anything about this disease, and I find it very interesting since it's pretty common and in white populations. So I want to go over who in the family can get it, where the mutation is located, and how to treat this disease. This disease is autosomal recessive because it occurs in chromosome 7, which can be seen in this picture, which is along the 1 to 22 chromosomes, and it can't not be sex-linked since it's chromosome 23, which is the sex-linked chromosome. That means a person must have a mutation in both copies of the CFTR gene to have CF. People who inherit one copy of the CFTR gene that contains a mutation and one normal copy are considered CF carriers, as noted by this yellow color, and green represents that they are not present with the disease, and red means they do have the disease present. CF carriers do not have the disease but can pass their copy of their defective gene onto their children, which is why, according to the CF Foundation, when two people who are carriers have children, there is a 25% chance that their child will have CF, and another 25% that their child will not have CF. When one parent has CF and the other one is a carrier, there is a 50% chance of their children being carriers of the CF and 50% of their children having the CF. Okay, now it's time to look at the location. The cystic fibrosis is caused by a mutation in the gene that produces the CFTR protein. This protein is responsible for the regulation of salts and fluids in and out of cells within the body. The specific mutation that I'm going to be focusing on is going to occur in the ABC transport membrane, but more specifically amino acid 85. And when we look at Stephen Wilkins' paper that addresses the structure and functions of ABC transport membranes, he talks about switching the membrane domain for providing alternating access, which this alternating access is driven by the binding of transport substrate along with ATP hydrolysis and production release. The ABC transporter transmembrane domain is the main unit for ATP binding cassette transporter proteins consisting of 6 alpha helixes that transverse the plasma membrane. The disease-causing mutations in the CFTR gene alter the production, structure, or stability of the chloride channel. All these things impair the transport of chloride ions and the movement of water in and out of the cells. This causes mucus buildup, which is also consistent with cystic fibrosis symptoms. A 3-nucleotide deletion causing the loss of phenylalanine residue is the 10th exon of the CFTR gene has been found in 70% of CF chromosomes. Now, many of you may be wondering, well, what can I do to cure this? It's a disease, let's just get rid of it. But unfortunately, there is not a cure for cystic fibrosis, and instead there are just medications that can be prescribed to ease symptoms or reduce any that are present. Some common ones are just medications that are prescribed for mucus buildup or lung infections, and doctors, some of the more advanced technology that we have, some doctors have been able to use CFTR modulators, and they're some of the newest medications. And depending on your age, they have a combo of medications that are within one, and some of them are Evalictor, Evactaftor, and Tizakaftor. Okay, now that we've gone over the three big main ideas of who in the family can get this disease, where it is located, and how to treat the disease, we can finally put it all together and have a little recap. First off, we know that cystic fibrosis is a hereditary recessive disease that affects the lungs and mucus glands. So, CFTR is a recessive gene, which means that both parents must carry the gene in order for it to be expressed in their child. The location of this specific mutation at amino acid 85 is a location of the CFTR mutation in the ABC membrane, which contains important transporters. So now that you know a lot more about cystic fibrosis, you can remember a lot more. Okay, now that we've gone over the three big main ideas of who in the family can get this disease, where it is located, and how to treat the disease, we can finally put it all together and have a little recap. First off, we know that cystic fibrosis is a hereditary recessive disease that affects the lungs and mucus glands. So, CFTR is a recessive gene, which means that both parents must carry the gene in order for it to be expressed in their child. The location of this specific mutation at amino acid 85 is the location of the CFTR mutation in the ABC membrane, which contains important transporters. So now that you know a lot more about cystic fibrosis, you can remember a lot more.